Hello everyone, myself Aditya and here I will discuss about my presentation topic and SEM paper. This topic is under the guidance of Dr. Saligram Prajapat sir and here I will discuss the question one by one. So the first question is analysis the time complexity of quick sort algorithm average case and provide step by step explanation of sorting process. So the answer is time complexity analysis. The time complexity of quick sort is O n log n, where the n is the number of element in the array. This is considered efficient and make quick sort one of the fastest sorting algorithm in the practice. So the next one is step by step explanation of sorting process. In the first series, we will make a pivoted element. Here in pivot element, select a pivot element from the array. The choice of pivoted element can impact the performance of algorithm and different strategies can be used. The second one is partitioning. Rearrange the array in such a way that all the element less than the pivot are placed before it and all the element greater than the pivot are placed after it. This ensures that the pivot element is in the correct sorted position. Third is recursive call. Recursively apply the about step to the subarray on the left and right of the pivot. This means repeating the partitioning step for each subarray until the entire array is sorted. The recursive end when the subarray contain only one element or are empty. Say for the fourth one is combine. Since the elements are rearranged in place during the partitioning step, no additional combining or merging is required. The fifth one is repeating until the sorted. Repeat the step 1 to 4 until the entire array is sorted. At each step, the pivot element is placed in its final sorted position. Reduce the size of sub-array that need to be sorted. So the next question is critically evaluate stars and matrix multiplication and compare its time complexity with traditional matrix multiplication method. So the answer is stars and matrix multiplication algorithm is the algorithm that aims to reduce the time complexity of matrix multiplication compared to the traditional method. It achieves this by using a recursive approach and divide the matrix into smaller submatrix. However, while the Starson algorithm provides a theoretical improvement in the time complexity, it also has some limitation and is not always faster than the traditional method. Here, the critical evaluation of stars and matrix multiplication is as follows. Advantage of stars and matrix. So here the advantage is as follows: reduced time complexity. Here the stars and matrix time complexity is n log 2 ki power 7, whereas which is approximately n 2 ki power 2.81. This is the improvement over the traditional matrix multiplication, which is time complexity n cube. Using the straightforward approach. Second advantage is efficient for large matrix. Stars and matrix is particularly effective when the dealing with large matrix, as a reduction in number of multiplication can be significantly reduce the overall computation. Now we will discuss the disadvantage and limitation of stars and matrix algorithm. The disadvantage is as follows. Overhead. Stars and introduce additional overhead due to the recursive call and matrix addition. This overhead can offset the benefit again from the reducing the number of multiplication especially for small matrix. As a result, the traditional matrix can be faster for small to medium size matrix. Second disadvantage is increased memory usage. Stars and algorithm require additional memory to store the sub matrix created during the recursive process. This process memory use can be problematic for large matrix as it may be exceed the available memory capacity. Now we will compare the time complexity. The traditional matrix multiplication has a time complexity n cube, whereas stars and matrix has time complexity n log 2 ki power 7, which is which in term of theoretical concept in term of theoretical time complexity, Starson is better than traditional method as it is lower exponent. In practice, the traditional matrix algorithm can outperform Starson algorithm for smaller matrix due to the overhead and extra arithmetic operation involved in Starson matrix. Starson algorithm become more advantage for larger matrix, where the reduced number of multiplication overweight the additional overhead. Now we will discuss the question number 3. Evaluate the Prim's algorithm for finding the minimal spanning tree and provide a real world scenario where it can be applied. Prim's algorithm is greedy algorithm used for finding minimum spanning tree in a weighted undirected graph. It starts with a single vertex and grow the MST by iterating, adding the shortest edge that connect an already included vertex to exclude vertex. Here the evolution of Prim's algorithm and real world scenario where it can be applied is as follows. Advantage of Prim's algorithm. The efficiency. Prim's algorithm have time complexity time complexity v square, where v is a vertex with adjacent matrix of matrix representation, and o e log v, where e is a edge and v is a vertex in adjacency list representation, where v is number of vertex and e is a number of edges. This makes it efficient for the design graph and relative efficient for sparse graph. Guaranteed minimum spanning tree. Prim's algorithm guarantees the construction of minimum spanning tree. The resulting tree has minimum total weight among all possible spanning tree in the graph. Ensure optional connectivity. Suitable for distributed system. Prim's algorithm is well suited for distributed system as it can be easily parallelized. Each node can be independently compute the minimum weight edges connected to it, making it efficient for distributive implementation. Now, the real world scenario for Prim's algorithm is as follows. The telecommunication network planning. A real world scenario where the Prim's algorithm can be applied is telecommunication network planning. Consider a telecommunication company that want to establish a network infrastructure connecting multiple cities with the least amount of cable used. The cities can be represented as a vertex, and cable required to connect them can be represented as edges. So the representation of Prim's algorithm is as follows. Here, this is the undirected graph given in the first box. Where now we will take take a minimum edges one by one, and we will form the graph at the end, which is n minus one edge, less than the vertex. Now we will discuss question number 3. Analysis Hamilton cycle and provide an example of how they can be used in real life application. Hamilton cycle is a path in a graph that visit every vertex exactly one and the start vertex. In other words, it is closed walk that transfers all vertex of graph without repeating or any vertex except from the starting vertex. Analysis of Hamilton cycle. Here the analysis of Hamilton cycle is as follows. MP completeness. The problem of determining whether a Hamilton cycle exists in a graph is known as MP complete, which means it is computational challenge to find an optional solution in polynomial time for large graph. Exhaustive search. Due to MP complete, finding the Hamilton cycle often require exploring all possible paths, which making it executive search problem. As the number of vertex increase, the search space grow exponentially, leading to computational intensive operation optimization. While finding a Hamilton cycle is challenging, optimizing the cycle for specific objectives, minimum distance or minimum effect can be approached using the heuristic algorithm or approximation technique. The real life application of Hamilton cycle is as follows. Traveling salesman problem. One significant real life application of Hamilton cycle is traveling salesman problem. The traveling salesman problem involves finding the shortest possible route for salesmen to visit a given set of sites, cities, and return to starting cities, covering all the cities exactly once. Hamilton cycle is diagram is given as follows. Here the diagram has different cities, and the matrix of these cities is given here. Now the question 4 is derive the time complexity iterative and recursive version of Fibonacci function and compare their efficiency. To derive, the answer is as follows. To derive the time complexity of iterative and recursive version of Fibonacci function, let analysis the each approach separately. So the first one is iterative Fibonacci function. The iterative version of Fibonacci function calculates the Fibonacci sequence iteratively using a loop. Here the code is as follows. So the code given in the box in black box. Now the time complexity of iterative Fibonacci is ON. since it perform a loop that run n time where n is the input number, each iteration involve a constant amount of work. So their time complexity grow linearly with n. Now the recursive Fibonacci function approach is given. The recursive version of Fibonacci calculates the Fibonacci sequence by recursively call itself. Here the code is as follows. So the code given in the black box which describes the recursive Fibonacci function. The time complexity of recursive Fibonacci function can be derived using a recursive relation. Let Tn represent the time complexity for calculating the nth Fibonacci number. The efficiency comparison. The iterative function is significantly more effective than recursive version. While the iterative approach has linear time complexity of On, the recursive approach has the exponential time complexity of On square. Sorry, O2 की power n. As result, the recursive function become increasingly efficient and grow large. The efficiency of recursive function is primarily due to the repeated calculation of same sub-problem, resulting in redundant work. In constant, the iterative function avoids redundant calculation and calculates a Fibonacci approach number in bottom-up manner, leading to better performance. Now the question one is write non-deterministic search and non-deterministic search sorting algorithm. The non-deterministic search algorithm. Non-deterministic search algorithm do not follow a specific deterministic path but explore multiple possible paths simultaneously which hope of finding a solution. One such algorithm is non-deterministic depth first search algorithm. Here the code is for the given non-deterministic first search algorithm is as given below. The code for the above NDFS is in given in black box. So the here firstly we will given NDFS function with problem and states. Here we will firstly take the condition with a problem. Now the non-deterministic sort algorithm. Non-deterministic sort algorithm are based on concept of non-deterministic computation where the multiple problem outcomes are explored at the same time. However, it is important to note that non-deterministic sort algorithm do not exist in practice since sorting is typically a well-defined and deterministic problem. Nevertheless, I can provide a simple exact example of a non-deterministic sort algorithm called non-deterministic bubble sort for illustrative purpose. So the code is given in the below black box. Now the next one is analysis and compare the class P, NP, NP hard, NP complete problem and provide example of each. Discuss their significance in a computer science and their potential in real world application. So the answer of the question is given here. In computer science, the complexity class P, NP, NP hard and NP complete play a fundamental role in understanding the difficulty of computational problem. Here an analysis and comparison of this complexity class along with example and their significance in computer science and real world application is as follows. NP class. A problem is in NP class if there exists an algorithm that solve in polynomial time. Means the running time of algorithm is bounded in by polynomial function of problem size. The significance of the NP class is given as problem is a class P has an efficient algorithm that can solve in a reasonable amount of time for large input. They are considered computational tractable and form the basic for many practical application in area like data processing, optimization and algorithm design. The next one is NP class, non-deterministic polynomial time. That a problem is in NP if a proposed solution can be verified in polynomial time, while NP stands for non-deterministic polynomial. It does not necessarily mean that problem is NP and can be solved in polynomial time. Significance of NP class is as problem in NP class. Class represent a class of problem where a proposed solution can be quickly verified even though finding the solution may be computational challenge. NP problem are great interest in computer science as they include many real world optimization decision and scheduling problem. Solving NP problem efficiently is significant open question in computer science with implication for cryptography, optimization, and artificial intelligence. The third one is NP hard, non-deterministic polynomial time hard. A problem is non-deterministic if it is a least as hard as the hardest problem in the class NP. In other word, NP hard problem is as difficult as harder than any problem in the NP. Significance of NP hard. NP hard problem represent a set of computational challenge problem that do not necessarily belong to the class NP. Solving NP hard problem optimally for all input is considered intractable and efficient algorithm for NP hard problem as a topic of active research. Many a real-world optimizing problem can be modeled as NP hard problem and develop approximation algorithm and heuristic for this problem in curricle. NP complete. Problem is NP complete if it is both in class NP and NP hard. NP complete problem are hardest problem in the NP and so solution to any problem. To any NP complete problem would be implies a solution to a NP problem. Example of NP complete problem includes a Boolean satisfiability problem set, the knapsack problem, the traveling salesman problem. The significance of NP complete problem are of utmost importance in computer science as they represent the not most challenging problem in the class NP. Now we will end the topic by saying thank you. Thank you for this supporting.